Hello Math 20-2. Today we are getting into our fourth lesson on quadratic equations. In this lesson we are going to make a connection between roots, zeros, and x-intercepts. So let's get started. Now the zero of a function is kind of exactly what it means. The function is equal to 0, 0 of a function. So we make the function equal to 0. So 0 is equal to, the function is 2x minus 6, and then we solve for x. So I'm just going to plus 6 to both sides. So I get 6 is equal to 2x. Then we get divide both by 2, divide by 2, x is equal to 3. That is essentially all that solving the function is. Now this next one here is a little investigation I'm just going to briefly go over with you. It says the graph is shown below. Determine the x-intercept of the graph algebraically and graphically. Well, graphically, that's simple. It's right there. X-intercept is right there. It's x is equal to 3. Algebraically, well, I look at this. What is my y value on that line? Your y is equal to 0. So I want to put 0 is equal to 2x minus 6. So I have again 6 is equal to 2x, x is equal to 3. Now let's take a look at this, the root of the equation. Anytime we say the root of the equation, we put y is equal to 0. It's always in the form of this, okay? If it was f of x, we say we're finding the zeros. If it's y of x, you're finding the root. So we end up getting 2x is equal to 6, x is equal to 3 again. So looking at these, they're all the same, isn't it? Now if I was to put this in my calculator, we'd find the zeros. We're going to see that a little bit more as I go to the next few examples. So in investigation 2 here, we're looking at a quadratic, which is more things we do. Now in a quadratic, we're either going to have 0 x-intercept, 1 x-intercept, or 2 x-intercepts. Because my graph could look like this, where we have 0. It could look like this, where we have 1, or like this here, where we have 2. And the way to find it using a calculator is we just calculate the zeros, second trace, and then we want to find the zeros, okay? Or what we do here is we square root it, and we're going to get to that later. So here we go. Example 2, it says, fill in the blanks of the equation f of x. So if I look at this, the zeros of the function, or something, the blank of the function of the graph of the equation, and are corresponding to y equals 0. Oh, y equals 0. So this is the roots. The zeros of the function. So as soon as we say function, that is zeros. Okay? And then we're looking of the graph, that means x-intercepts. And the roots are when y is equal to 0, are all the same. So see how each one relates? Zeros refers to the function, x-intercepts refers to the graph, and the root refers to when y is equal to 0. Okay? Now, here we go. Here's a little fill in the blank to try and elaborate this and show this a bit more. We have the graph of the function is there, so find the x-intercepts. My x-intercepts are here and here. They are 2 and 3. Now it says find the zeros. Well, this is already factored for us. Make that equal to 0. So I could have x plus 2 is equal to 0 or x minus 3 is equal to 0. So I'm going to end up getting 3 and negative 2. Why? Because when x plus 2 is equal to 0, x is equal to negative 2, x minus 3 is equal to 0, x is equal to 3. Right? Just rearrange. Now this next one here is we want to find the roots. Well, I'd have to factor and then solve, which is the same as this. So I'm going to get negative 2 and 3. Or else we just find the zeros, type that into y equals, and find the zeros. Okay? Now, here we go. Let's take a look at example number 3. It says, consider the following function. Alright? Now, describe how the features of a graphing calculator can be used to determine the zeros. Well, that's easy. I'm going to put this in here. Clear, window, oops, zoom, 6, make my window standard. There we go. So let's take a look here. Now, we have y is equal to 2, and we have x squared minus 7x and plus 3. Now I want to graph it. There's my graph. How do I find the zeros now? Okay, let's try and figure this out. How do I find my zeros? I want to second calculate, find the 0, and it wants left bound. Well, that looks left bound. Enter, because it is that way. So here's my intersect. We're that way of the intersect. Then right bound. That's to the right of the intercept. Then my guess, my intercepts are on there. I get 0.5 and 0. So x is equal to 0.5. Now let's find for the other one. And we want my 0. So left bound, I have right there. Right of the intersect, because that's the intersect. Right there, that's right. Now my guess, because right there is what's in between, that's around in between, I get 3. Okay, so those are my 3. That's how I did it. I found the zeros on my graphing calculator. Next it says state the zeros of the function y is equal, or for this. Well, state the zeros. Well, the zeros are x is equal to 1 over 2 and x is equal to 3, like we found before. Then it says state the roots of the equation. Well, that's the same. If I was to graph this looks like something like, like this here. I know it's an ugly graph, or beautiful I might say, and my same is equal to 1 over 2 and x is equal to 3. Or it is, we could say 1 and 2, half and 3. Okay, so it's, or we could just say 1 over 2 and 3. You don't even have to say that x equals to this. Now it says, that should be an and. Now it says draw the graph of y of this here on the grid and state the x-intercept, y-intercept of the graph, and then label them. Well, my y-intercept is going to have to be 3. So this here has to be my y-intercept. My x-intercept is 0.5, and this here is 3. And that's it. Okay. Let's take a look at our next question here. Number 4. Algebraically determine the zeros of the following equation. So we want to do this algebraically. Find the zeros. Well, we make the equation equal to 0. 0 is equal to 3x. Then we have 4x subtract 9. Now, looking at this, if this here is equal to 0, that would be 0 multiplied by whatever number that is. Doesn't matter what that number is, because 0 multiplied by anything is 0. So I could have 3x equal to 0, or vice versa. If this is equal to 0, doesn't matter what that is, because 0 multiplied by something is 0, or I could have 4x minus 9 equals to 0. So I solve, divide by 3, well, that's just going to be x is equal to 0, and this one here, we end up getting 4x is equal to 9, divide by 4, divide by 4, so I get 9 over 4. So these are my 2 zeros. Alright, let's take a look at the next one. Same idea. It says, we have this here now. Is there anything I could factor out? Because this looks complicated. I think there is. I'm going to take out this 5. I could take out a 5. Good. So I have 5, and I have x squared plus 3x minus 4. Okay, now, that looks factorable, doesn't it? I'm going to use my trusty box method. So I have negative 4, and I have 3. Well, I look at this. They're going to have to be different. I have 4 and 1. That looks like it'll work, so I'm going to have to put 4 and 1. And this is, the positive must be bigger because it's plus 3. So I end up getting x minus 4, or x minus 1, and x plus 4. Now to solve this, I know this could be 0, that could be 0. So I have x minus 1 could equal to 0, or x plus 4 can equal to 0. So I end up getting x is equal to 1, and x is equal to negative 4. So I subtract 4. So 4 plus 1 plus 1. Okay? There we go. Last question. It says, algebraically determine the x-intercepts of the graph of the function with the equation like this. So it wants us to do this again algebraically. Okay? So we could do it, and we could always check our work using our graphing calculator. But we're going to do this algebraically. Now, start off, is there anything we could divide this by? No. So I'm going to have to use my box method here, and the more complicated one. Okay, so I have 3 times 10 is 30. Okay? And that's all over negative 11. Now, break this up. Both of them must be negative, and they're getting bigger because this is positive, so that means they're the same. That's negative, so I'm going to have 5 and 6. 5, 6. There we go. So I have 6 over 3x, and I have 5 over 3x. Well, the 6 can be simplified down. These cancel. If I look, this and this cancel off, so I'm left with 2 over x and 5 over x. Alright, so that's factored out. We have, that's 3x. We have 3x plus 5, or sorry, minus 5, because they're both negative. Negative, these are both negative. Minus 5, and I have x minus 2. There we go. Now we want to find my zeros. Okay? And then we state the y-intercept. Well, the y-intercept is 10. Is equal to 10, because it's always the constant. So let's find my zeros. So we're going to say 0 is equal to that. 0 is equal to, or, alright, solve for each. I plus 5 for both sides. There we go. Divide by 3. So I get 5 over 3 is equal to x. And this one here, I just say plus 2, and I get 2 is equal to x. So these are my two solutions. And my y-intercept is 10. Okay? If I want to double check it, I would just go into my trusted graphing calculator. And y equals, we're going to put this in here. We have 3x squared. Oops, x squared. And then we want to plus, I think it was plus, yeah, minus 11x. And then we have plus 10. And we graph, and if you look at it this way, oh, and I have two things there, it says, but according to this, it's very close to 1, so I'm going to have to, I'm going to zoom in right here. Let's take a closer look. Ah, and I look at it, it does cross twice. Okay, so if you see that there, it does cross twice. And I'm going to push enter again so we zoom in even more. Ah, so if you looked at it without doing it algebraically, you might think there's only one. So now we can calculate my zeros. We want left bound, there, right bound, there, guess, we have there. So 1.66, hey, that's the same as 5 over 3. Okay? 5 divided by 3, look at that, 1.66. Good. Now let's try the other one. And we're going to calculate my 0. So we're going to go left bound, there, right bound, right there, my guess, right there. I get 2 and 0. And that's the same as what we got before. Alright, so there's an easy way to double check. So there you have it. That's lesson 4. Hope you understood. See you tomorrow.